Hi there, Kaylee. I guess I'm trying to keep up the good work with this debate happening, this asynchronous debate. So the resolution was develop the moon. I'm just going to respond to some of the issues I think I saw happening in your response that you gave. So some of the points that you bring up, and they're pretty salient points. The first is that resources will be depleted by 2080, 1.4% decrease globally of this material that we have, and there's a lot of numbers in that treaty that you or in that report that you mentioned about these figures, where they come from. So resource depletion, and you talked about how this moon development could be a long-term strategy to solve this problem, but there's a lot of problems just assuming that the moon is the answer, and a few of them were brought up in my my partner's speech earlier on. He talked about how expensive it truly would be to establish a mining apparatus on the moon, to develop it, like you said, for human lives on Earth, for their benefit. And so using the numbers that were brought up that weren't disputed in your speech, I did some calculations for what it would cost just for 10 years of operation. But mind you, you would have to multiply that number by at least 4 or 6 because of this 2080 number that you mentioned. We have like that long of a problem before it becomes like kind of fatal and we're all like scrambling for resources. So I did the calculations, and based on this notion of it taking 35 billion at least to build a moon base, plus 7.3 billion a year to manage, 450 a person to get up there to the moon. I'm assuming 10 astronauts. That's probably a good enough thing to get a mining operation started on the moon, that is. And then it was 20 billion a decade for tools. That's a lot of money. And then to develop the nuclear power plants on Earth itself, it's going to be 9 billion to construct. Using all those numbers, I ran that, and that's $137 billion a decade just to run this moon apparatus, this mining operation. And then you brought up the point of like governments being able to share this cost, that maybe it's something we could do as a world instead of as singular nations trying to do this. But 137 billion over 10 years is a lot of money. It's far more than most governments will spend on the military in 10 years. Except in the exception of war scenarios, but this is a lot of money for peacetime governments to handle when there's like welfare issues happening. There's all sorts of economic strife, as it is, like in Europe and in America even. There's economic hardships happening, and $137 billion over 10 years is a huge chunk to be taking away. NASA only gets around $14 billion a year. And so think about that number, like $137 billion, that's quite a bit amount of money. In addition, I did some calculations based on like the safety involved in going to the moon, because that's another concern. We need to be concerned about human lives, if that is what develop means to make human lives for the better. So there have been 533 people to reach below low Earth orbit, meaning like, get to low Earth orbit, that is, like escape just what it would be like in a plane to kind of experience what weightlessness feels like. But the people that actually get to space, 533 of them, 38 have perished in that attempt. And so if we run that out, that's about a 7% fatality rate just off the bat, just to try to get to space. So let's say we keep sending these miners up there, we keep doing this year after year for decades. We want this apparatus building. While there is the prospect it would become a safer procedure over time, 7% means we will have fatalities. There will be explosions, there will be mistakes that happen. And so with the 7% fatality rate as it stands, this is a very dangerous prospect. And additionally, let's say this 7% failure, this 7% death rate, let's magnify that. So they're on some type of ship that happens to fail. We lose all the materials, all the money we spent on the materials, and the manpower to get them up there. And so that number I threw out, the 137 billion, that would only increase with failure. In fact, as we can tell, government projects tend to run a lot of money. I have a friend at UCLA, is a physics grad student up there, and he's working on the tokamak reactor in France. It's a fusion reactor that would use the helium-3 you proposed to mine on the moon. And you know, some of the it's happening in France, this tokamak reactor. It's called ITER. And it's costing 16 billion so far to build, and so that 9 billion just to build these reactors, that was a generous estimate. So this 16 billion is 3 times the original figure. It's not even going to be testable until 2020. It won't even be finished construction until 2019. They've been working on it since the early 2000s. So this is a long, hard process. Fusion is difficult. And then the full experiments with the helium-3, the deuterium, the tritonium, all these materials we would be getting from the moon, it wouldn't be operational in this ITER tokamak reactor until 2027. So, it's the best we have on Earth right now, this project. It's currently being shared. The cost is being shared, like you advocated, among many of the nations. And it's just extremely expensive. And moving on to your other point about orbital concerns, I agree, it's not really a big deal to remove that much mass from the moon, not a big issue, but we need to be more concerned about human lives, cost of government, and if development means bettering human lives on Earth, we need to be concerned about how much it's actually going to cost in terms of lives and money over time in an economy that's not so strong globally, and in a time when it's kind of dangerous to be doing this. We don't have the technology yet to really be good at this, to make it something worth doing, when we have most of the materials we need here. We have at least till 2080. That's a long time to develop and make things better, but developing the moon's not the solution. In fact, it'll contribute to the problem.